All right, good afternoon, everyone. We're back in the water stream, and now we have Nichole Harper from Pacific Flow Control with us. Nichole is a project manager and estimator for PFC for the last year and a half and has been a part of the water and construction industry in some form or another for the better part of the last 15 years. With a diploma in environmental engineering technology, she's currently completing her Bachelor of Technology in environmental technology management rather. This year, she's a lifelong learner and always looking to improve understanding of products and systems to devise cost-effective solutions best suited for the unique needs of our growing province. Please welcome Nichole.
Hey, everybody. Thanks for having me back here again this year. I know I'm late in the day on one of the last days here, and so I know you've heard a lot of wonderful speakers already, so I'm going to try and keep this light and entertaining and get us through this next 45 minutes. So everyone always talks about safety on the job site, and we're always talking about PPE, confined spaces, slips, trips, and falls, and those are all really important things, but no one ever really considers the pressure on the pipe that they're working on. Like carbon monoxide at a site, at a mine, and unless we have a gauge on it, we aren't physically seeing the risk. And that's something we can take for granted and become really complacent on really quickly. So again, 30, 40 years ago, the risk is contained within that pipe. And if anyone was here last year when I was talking about Peter the pipe layer and Bob the backhoe operator, they were working in a blasted trench Friday afternoon of a long weekend. And so Steve the super takes Ivy the inspector out for lunch pops, and wouldn't you know it, everyone's home by 3 o'clock in the afternoon. So we're just going to roll into a video real quick here.
Essa força que você vê aí no seu vídeo, jorrando intermitentemente, não é, Lara? Durante 45 minutos.
Exatamente, Gustavo. Começou por volta das 6h20, o nosso helicóptero chegou em seguida, e o que mais impressiona é que tem uma residência de 2 pisos, Gustavo, e que no primeiro momento até o teto estava em pé. Logo em seguida, questão de minutos, tudo veio abaixo.
Desperdício de água aí violento. Eu já até pedi a informação à SEDAI, e eles têm como nos passar de quantos 1000 litros foram desperdiçados com esse estouro. E eles têm como nos informar isso. Vai falar que não tem como prever isso agora, porque imagine você, seu veículo ali estacionado, você acorda e ele está boiando, tá? A sua casa destruída, levada quase, praticamente, né? Levou teto, levou pedaço de parede e tudo mais. E os moradores ali, parece que estão no meio de uma enchente. Já viu aquela chuva que cai torrencial? Pois é, foi o que aconteceu, mas num ponto só de Campo Grande. Num ponto. Você tem a estrada do Mendanha completamente interditada. Aliás, o nosso repórter Hernani Alves está ao vivo lá cobrindo tudo o que está acontecendo. Acabou de chegar. Você tem aqui na Record. Muito obrigado pela gigantesca audiência nesse momento. Você vê imagens do nosso Mochilink, o Corpo de Bombeiros trabalhando ali e até mesmo...
So, in this video, I'm certain that there's loss of life. You can see the surrounding ground was blown apart, presumably asphalt, for a good 100 meters in each direction. And, if anyone can speak Portuguese here, feel free to translate. I did catch agua violente and something like maybe 40, 50,000 liters of water. I'm not 100% if this is Peter and Bob's fault, but if you're one of these altruistic folks in the Lower Mainland who's abiding by the water restrictions that we have, instead of the guy that lives behind me that hopes his fence is going to grow taller if he waters it for 3 hours a day, your yellow lawn, if there's anything left of it, it's going to turn green again. So again, this is going to be a really crappy day for someone. And, that water has obviously overwhelmed everything pretty quickly. And it's a great reason to know where your valve boxes are, where your isolation valves are, to make sure you're cleaning them out and exercising those valves regularly. Not like you're going to get this under control really quickly, but, you can try and mitigate the damage to property as much as you can in a catastrophic failure. So real quick agenda here, we'll talk about the difference between water and water and air pressure. We'll get into some thrust blocking, hydrants, PVC pipe, double block and bleed. And if I have time, we can get into some gasket compression. So water versus air, again, another quick video here.
conceptions we find though in the field, folks don't understand the difference between water and air.
So water is more, so air is compressible. So it's going to act like a spring and explode, whereas water is just like a moving wall. It's not going to have, unless you see something like that last video, it's not going to have the same effect. You're going to have a crappy day. You're going to catch a cold because obviously this failure is going to happen in December and you're going to work a 16-hour shift, but you're still going to have 10 and 10 when you go home, hopefully. This next video, it's a little bit older, but it doesn't lose its poignancy. And again, comparing the difference between water and air. Oops. I guess that one's not playing. So essentially all it shows is a water tank, just having a little explosion and then the water peters out, as opposed to an air test that's happening underground and it essentially blows up everything in its wake. And then, oh, it's playing on this screen. Yeah, there we go. So yeah, again, a bad day. You're picking up body parts. You're calling someone's loved ones, telling them they're not coming home. So really the most important thing, water, air, they are both dangerous. Air is far more dangerous. So thrust blocking, we'll get into this. Earth loading and restraints. I'm not an engineer and we aren't an engineering firm, but we do have a little bit of collective experience over the years with restraints. So we can help with some guidance. And we never really used to be a part of these conversations because there are a lot of seasoned guys on site who have a lot of knowledge, and they would just see a drawing with some restraints or earth loading, and they would just say, let's just stick some concrete blocks in there, some bags of concrete. And, they were right. That's really all you needed a lot of the time. And we're finding now with the exodus of those older guys, there's not enough time with mentorship with the younger guys that are coming up. So they're losing a lot of that inherent knowledge that these guys have gained over the years. And, it's always easier to ask someone else. YouTube University is one of my go-tos. And so, but again, restraint in general is losing ground, and we will spend as much time as it takes and, on the phone helping you guys through this and to help point you in the right direction. Then what happens after we spent all that time on the phone is Johnny gets to site and none of it's been relayed. So he's pulling his hair out, trying to explain it all. And again, we've been on job sites before where I won't say where, but they're literally holding the pipe back with chains and an excavator because nobody ordered concrete. It happens, everyone makes mistakes, but these are big problems. So if you close that valve and there's pressure pushing behind it off the line, you're going to blow that balance spigot right off with that pipe if it's not all restrained. So again, Johnny gets to site more times than he can count. He says, hey man, this isn't restrained. And, they say, yes, it is. Look, there's MJ restrainers and breakaways. And he says, yeah, your valve is restrained to the pipe, but your pipe's not restrained. So then, everyone thinks they're really smart too these days where they think they're going to get it all done in one hole. But, your pipe is no longer restrained. So you're going to need some kind of thrust block in place, or you leave your pipe in the ground and you dig your new valve, new PRV 45 feet, away from where you're currently installing this valve. So real quick here, a 2-inch cap at 100 PSI is 314 pounds of force. That's not going to feel great, maybe break a kneecap. Whereas a 24-inch valve or cap at 100 pounds of force is 45,000 pounds. And that is dead bodies. That is body parts. That is a bad, bad day. We've seen, and this can be very deadly. So Brandon has, in his previous lifetimes, has seen these 2-inch caps go through one side of a house, through another, while pressure testing for anchor loading. And you can just compare water to the equivalent of a cannon. Instead of using gunpowder, we're using air and water. This past Friday, actually, Pierre, one of our technicians on the island, he was doing some hydrant servicing, and out shoots this golf ball size rock at 125 PSI. So again, if you're servicing hydrants, don't stand in front of your nozzles when you're flushing them. This example here is a line stop we did for our friends at Metro Vancouver. This is a 42-inch line stop, 230 PSI of force. So you're looking at 320,000 pounds, right? So, you know, the worst part about this, if this goes bad, you're not flooding out basements, you are taking out a mountainside. Again, a very bad day. So thrust, the restraint and bury requirements. This is a great tool I'm going to show you here. So any engineer that you're willing to hire is going to do the same thing that we will. And we're going to go to the EBA website, and we are just going to plug in these few things here, which is your pipe size. And you're going to go plug in your soil type, the type of pipe, your factor of safety, your trench type. Typically, we err on the side of caution, and we choose a poorly graded soil. We choose a poorly graded trench, just to make sure we're on that. Typically, in the Lower Mainland, you'd pick a type 4 or 5 trench, right? But again, err on the side of being conservative. Bury depth, this example here was done for Alberta, where you have to put your pipe 8 feet in the ground to avoid that frost line. And again, what trips people up is that end type, or the fitting type. So a dead end, whether it's a cap or a valve, is going to be a dead end. And so you just plug in all those numbers, and it's going to spit out how much pipe you need to have buried, or or how many restraints you need to have. So this particular example, you're going to need 3 sets of restraints over 3-4 sticks of pipe. Again, real quick, everybody has a computer in their pocket nowadays, unlike what my high school teachers said. So give it a quick Google. It's readily available. I believe there's also an app for this. Just make sure you're covered if you're going to be unearthing a lot of pipe. And here is the opposite example, right? So we have our 2 valves in there, our 2 line stops at each end that are encased in concrete. We leave all of our pipe buried, so your pipe is in compression. Whereas if you're using restrainers, those rods are going to be in tension. So, you know, either way works. You can get to that calculation the same way. One is just the reverse of the other. But either way, you're going to be safe if you have your piping being restrained. And these are the typical types of restrainers. I'm sure everyone in this room has seen them at some point or used them. Typically, we use split MJs, split hub and flange, and restrained couplings. Engineered thrust blocks, deadmans, and reverse thrust blocks. So a lot of people have kind of a tricky time understanding the difference between them. A reverse thrust block is when you rod back from your valve to that thrust block. This is an example of a job that we helped out Metro Vancouver with. They're installing a new PRV in the middle, and we have our Mueller valve inserts on each end, and they needed to restrain it to the pipe and then again back to thrust block. This is a very high pressure zone, so they were able to do that. And again, rather than they're cutting into this piece of pipe, they restrain it back, because if they don't, they put pressure on it, they're going to end up with that valve and that pipe downstream 2 blocks away in someone's roof. So working around thrust blocks, so the great thing that I love about these presentations is that you guys who've been around for a while, you come after and you tell us all your secrets and you tell us all your stories, you know, because now it's okay to laugh about it. And you also don't know how to post anything on YouTube or social media. So they're, you know, like my dad, you probably try to avoid the family group chat or pretend you're not in it either. But, you know, we know you're there. So I won't tell you which city this happened in, but right here, oops. Right here, these guys had this exact example. They had a 36-inch main at a corner, and they had their boulevard running parallel to that 36-inch high pressure main. And, you know, they are, with all of our forests burning down across BC, they wanted to make their boulevard pretty and plant some trees. And they aren't a hazard at all when you're trying to pull into traffic either, I might add. But so they dig these, they have this landscape contractor come out, they dig these big, beautiful tree wells. And these guys, they don't know what this concrete is doing in the ground. They pulled their BC1, they did their due diligence. But again, they've never put pipe in the ground. They don't know what this is for. So they keep digging and they end up undermining that thrust block. And this 36-inch PVC main explodes. Poor guys, you know, long story short, there was more than just basements flooded. They ended up flooding out the better part of downtown because that pipe gave way. So again, they don't know what they're doing. They, you know, they've never laid pipe a day in their life unless it's somebody's sprinkler system in the backyard. And, you know, they just didn't know any better. So 36-inch pipe, roughly 320,000 pounds of force of water coming out. So that's going to move a cement truck full of water if it lets go. And that's a really bad day for some folks. You won't have this back up and running in 15 minutes. You're going to be there all day. And the next day, followed by pressure testing, hyperchlorinating your system. And again, knowing where those valve boxes are and exercising your valves regularly is super important. But, you know, like you can see that right pretty easily. If you're removing this dirt, undermining it, that concrete's going to let go really easily. So this next case study is a really good one as well. This was done for our friends at the Corporation of Delta. So this line right here, this line right here is the New South Fraser Perimeter Road, and they have a PCCP C301-303 high pressure sanitary line running through Burns Bog, that's what it is. And they came to the conclusion that it's probably not in their best interest to have this line continually operating under the highway and going through one of the most environmentally sensitive areas in the Lower Mainland. So what we did, we came in and installed a line stop, and they're going to cut and cap that line so it can redirect flow down their new 30-inch line. And so, you know, it was a great project to work on. And this is the design they had come up with. So Brandon, before he became one of the co-owners of Pacific Flow Control, he was a young buck fresh out of school. And as everyone out of school knows everything, he looked at this thrust restraint design and he says, what kind of idiot designed this? I've never seen so much concrete in my entire life. However, you know, with age, we've come to find that maybe this isn't so over-designed. You know, a little wiser, a little older. But as you know, I won't take away the fact that every time a new engineer looks at a drawing, the factor of safety increases 10%. So again, but it is a lot of pressure, 36-inch line, PCCP dead-ended at 75 PSI. So here, these guys are framing it up, getting all that rebar in, and these anchor bolts that you see here are very important, and they will come up again shortly. So we've densoed all our fittings up. We're continuing to form it up. And this is our final product. So that is one heck of a thrust block. So the line stop we have on top is what is going to stop that flow from continuing on through that pipe. And that is going to be installed right here. And if anyone in this room doesn't know at this point what a line stop is, it's just a temporary valve that we install with a piece of equipment. It's going to open up inside that pipe, create a seal to stop any flow from going much further so we can cut and clean out the remainder of the pipe. So that is just us cutting out, that's going to be our drill cutting out on top of that pipe. This is our line stop folding head. It's going to fold up inside this can here, and we're going to drop that on top of that valve that you saw earlier that was concrete encased. And that is going to open up inside that pipe with the force of the sewer all around it. So here we have it stopped, cut, and we are putting on what is now a reverse thrust block with this plate and cap here. So we don't want to put, while it is a beautiful thrust block, we don't want to pour it twice. So that's where those anchors came into play earlier, because now we can rod back that plate back to that thrust block, and it is holding all that force back for us while we wrench it all in. And so this bolting up here, if anybody, so this is super important too, but I don't know that I'll have time for it. If anybody can, oh, there it is. If anybody can do this in less than, let's say, an hour and a half, 2 hours, you send them right back into that hole because they haven't done it right. It should be done slowly, progressively with the proper torque values. And here is that beautiful finished product ready to be buried and backfilled. Holding back roughly 75,000 pounds of force too. All right. Hydrants. I know you guys have just heard some really great presentations. Darcy from Tawasin and Carla yesterday from Clow. I'm sure she gave you guys a great presentation, and I'm sure they addressed this, but I'm going to have to drive it home here. And I'm sure they asked you the same question. Has anybody in this room seen a hydrant cap blow off before? Yeah. Okay. Have you seen a main valve shoot out of a hydrant? Mm-hmm. Was it not one of the most violent things you've seen in your life? Yeah. So our guys, they touch anywhere from 7,000 to 8,000 hydrants a year, give or take a couple hundred. And the worst thing about doing something that often, that repetitive, is the complacency. And then, sorry, the worst thing is working in groups of two. You know, embarrassingly enough, communication sometimes gets the better of us, and you're working in groups of two. Buddy says, yeah, I bled it. You know, I cracked the valve, closed the valve, bled it already. And the other guy, your partner says, Roger that, pal. And he starts pulling on the main valve. I don't know if anyone here knows the Eastern Canada rep for Mueller. But this happened to this person. So he's actually missing an eye because of that, exactly that scenario. He was doing a demo in a city, and a city crew told him that they had bled it and closed it. And he was on top pulling away and awkwardly, pulling on it awkwardly. And then when it came up, it smoked him in the eye and popped his eye out. So if it can happen to a guy who literally teaches the course on how not to have this happen, it can happen to anybody. He's touched hundreds of thousands of hydrants, right? One of our old competitors we bought out a couple of years ago, he's probably about my height, maybe a little bit shorter. He's a wonderful, fantastic technician. He actually built these custom steps to thread into the 2-inch port side. So he can get on top of the hydrant and crack it open, so he doesn't need a crane truck like us lazy guys. But so anyways, he gets on top of it, and he's bled it. He's pulled the main valve. So he didn't, where am I here? He closed the valve. He says he bled it, and he gets a phone call, and whatever reason, just out of habit, he closes that main valve again and goes and talks on his truck for the next 20 minutes, booking a job, talking to a customer, what have you. And then he comes back 20 minutes later. What he didn't realize is that main valve was still bleeding out, and the air was compressing, and it was a non-draining hydrant or non-draining valve. So as it's compressing, he gets on there, cracks it open, and all of a sudden, boom, right under his chin. He wakes up a couple hours later to the neighbor frantically calling 911 because she thinks he's dead. He wakes up laying in the boulevard, a couple of days in the hospital, but he was back at it. Super lucky he didn't die. Anything could happen, right? So just be very careful when you're working on hydrants. They are extremely, extremely dangerous. I don't know if anyone's seen this one. Poor fireman here. We'll take a look at this guy. everyone always laughs and they're like, doesn't this idiot know that it's charged? Yes, he knows. He touches more hydrants than a lot of us, I'm sure. But you know, there's an emergency, your adrenaline kicks in, you're full of testosterone, and the frontal cortex just doesn't operate at peak. So worse than his crappy day is that he's going to hear about it from his fellow firemen every single day when he walks into that fire hall for the rest of his life until he retires. So again, that's a 2.5-inch cap blowing off at 100 PSI. He just got hit in the belly with a 314-pound hammer. He's not going to feel great, but he is going to go home. So what's worse is if that he pulled on that main valve and that comes shooting out 6-inch nozzle comes shooting out 100 feet in the air, what have you, 100 PSI of water. It's going to be a lot more water and a lot harder to get back under control. So here, an example. So, oh, go back. That's what I want. So we're going to close this valve and then we're going to bleed out this port. And we're not going to close it out. We're going to purge it out. We're not going to close it. All right. And this valve, you're going to close 3 turns per inch. So you're going to be at 23 turns, roughly, give or take. If you're not getting that, you might have an issue, which we're currently dealing with one actually in Port Coquitlam. So once this hydrant is purged off, we're not going to close it. We're going to leave it open. And then we pull the bonnet off and pull the main valve out. If that doesn't make sense, please go talk to your foreman because you may need a little bit more training. You can't be messing around with it. You're going to lose an eye. You're going to break a jaw. And again, as we said, if this can happen to the Mueller rep, the person who literally does this for a living, you know, it can happen to anybody. Working on PVC. So this was the main focus of my presentation last year. I will not get in depth the way I did last year. But again, we will touch on it quickly because it's super important. PVC has a catastrophic failure mechanism, shards everywhere. So in the early 90s, there was a lot of wisdom about PVC pipe, and the salesmen, they didn't know better. They were just being told what the manufacturer was being told. And that was finally a pipe you can bend. You know, fast forward 35 years, and we know that is absolutely terrible, terrible information to be giving out. It came back a couple of years ago. Okay, only a little bit of deflection in the bell and spigot. And now more recently, they've come back and said 0 deflection anywhere. And there's a drawing that came across my desk recently, and it said deflection in the pipe as per allowable. And I wanted to call that engineer up and be like, no, sir, do not do that. Don't put those notes on your drawings at all. No deflection in that pipe at all, period. But, you know, so when you deflect this pipe, you're putting an external force on that pipe that it's not built for. And if you're taking a gas axe or a, you know, you're tapping a deflected pipe, you know, just make sure you are wearing all your PPE, make sure you're doing it safely, make sure you're doing it right. And, you know, there's deflected pipe all over North America. We're going to see this pipe exploding more and more as it gets tapped or anything happens to it, right? It doesn't take much when it's already in, has those forces loading on it. And, you know, we'll get to site sometimes, and our technicians, they have great pictures. We'll see a main deflected 90 degrees over about 4 or 5 pipe bends, and it's very frightening. We won't let them tap it when we see stuff like that. You know, find a new place because we're not going to put our guys at risk. But yeah, just, you know, get your blankets out, cover the pipe like you're supposed to when you're tapping it, and just take all the proper precautions, wear your eye safety gear, everything, right? And if anyone needs to have, you know, Brandon come in, I will offer Brandon services of presentations because he's very charismatic. He will come in and talk to your guys half an hour real quick on PVC safety. Just if it needs to have more impact, we're always happy to do that for you. So again, we will see what happens here with some pipe blowing up. I don't know about you, but you can kind of see some deflection in that pipe to start with. The good thing is he is using a double strap stainless steel brass, stainless steel strap saddle. So that is the good thing. However, this guy's going to go crying when he's sitting in front of a judge looking for sympathy, saying, well, hey, man, it's not my fault. The pipe was bent. And judge is going to say, you tapped this wrong, pal. You used a drill. You're tapping way too fast. You're putting a ton of pressure on it. But the good news is, like I said, he used the right saddle. So mountainside communities where they are dealing with a lot of this blasted trench, you're going to see a lot of this bent pipe. And, drill and blast guys, they are not really known for their finesse. And so they don't care if you need a clean radius. It sounds like a laborer problem with a chipping bit or a jackhammer. So, but people make it work. You want to get home Friday, right? It's a long weekend. So in this particular mountainside community, they're hot tapping a 12-inch high pressure main. And, it's not that old, 2-3 years old. And someone bent the heck out of this pipe when they installed it. And this guy goes to hot tap it and he gets blown out of that hole, 8 feet out of the hole. He finds himself sitting on the asphalt. He's dazed and confused, doesn't know how he got there. And the general manager looks at us and says, well, it was a really good thing he got thrown out of that hole. And we're just like, what? Well, because all the water, he could have drowned. And I can think of a better way to get out of an 8-foot hole. But again, we got to look on the bright side. He is right. At least, he was safe. So this guy clearly wearing all his, all the proper PPE here, as you can see.
Oh, that's cool. Yeah, you don't want it to pop off when you're done, tell you. It's almost like getting home from the face. Damn. The whole thing from get out of that thing.
Damn. Yeah. So, you can see right from the start with this guy, he wasn't using the correct saddle, single strap saddle, probably point loading the heck out of it, likely for ductile. And, you really need to be using the proper saddles. Ideally, like we saw in that other video, a thick stainless steel double strap saddle fitted to the pipe at the top of the OD range. But, like I said, this guy, all his PPE, so he's safe. This here, quick Google, it'll come up in the first 5 searches. This is what is called industry best practice. So when you are sitting in front of that judge, him and the lawyers that you're going to be dealing with, they're going to have this same document and they're going to ask you questions about it and why, let's say you have a major incident, you sent mega gallons into the Fraser River and a couple of houses, they're going to just say, they're going to ask you all the questions having to do with this, and you should have a good idea what it says so you can have the right answers for them. So double block and bleed single valve isolation is what we're going to get into next here. So this has become a real big thing in recent years, just due to a couple of catastrophic failures that have happened, loss of life incidences that we will not get into. And, the waters industry has been pushing back because this is more of an oil and gas standard. But if you're in a confined space downstream of live water, they will say now that you need double block and bleed. So 2 closed valves with a purge in between and a bleed is what is happening here, because all of the valves in the infrastructure that was put in 50 years ago, we don't have good maintenance records on them. And so it's not a great idea to put people in a confined space downstream of a 54-inch butterfly valve that has not been exercised in 40 years. So obvious reasons, right? And, we just don't need anyone getting hurt. And, there's a lot of close calls, few very close calls, but because of that, WCB is deciding to hammer down on single valve isolation. And, you know, the easiest thing to do is to take your work out of confined space. So what's happening now in a lot of towns is that they're putting these PRVs above ground. And, you know, it's another thing you could do, just your single valve isolation with engineering sign off, or a combination of both. So we do a lot of these different combinations here. This is one of our, you know, this is what we would typically do, 2 line stops in line. You guys in the municipalities, you're likely going to have a lot of this, but we can do any of these combinations here for you to make sure that your guys are working safely on your energized infrastructure. This next case study, Metro Vancouver, 42-inch single valve isolation. So what's happening here is this is a 230 PSI line that we're working on. And what we're doing is a pressure ladder. So here you're working at 230 PSI. Our line stop is rated to 250 PSI, and your engineer is going to want a 2-to-1, 3-to-1 factor of safety. So now we step it down and we have 115 PSI here. And then we have our next line stop in that has a purge point on it that's going to blow off whenever you reach that 115 PSI. And then down here is where you're cutting into this pipe and you have 0 PSI. So that is what, even though it's a double block and bleed, it would be considered a single valve isolation because there's pressure on both sides of the head. Real quick, this is just what we would be installing. I'm not going to talk about welding procedures. Just make sure that you have proper welding procedures and that the people working on your live infrastructure are trained for it. And we have our valves concrete encased here. And our line stops going in. So again, here's that pressure ladder again, 230 PSI here, 115 here, and its blow off is right here for when that pressure exceeds that 115. And then this is what it would look like when you're cutting into that pipe. So nothing's ever perfect on the inside of a pipe. And you just want to monitor that blow by in the event that it gets worse. So if it gets worse, we can reset things to try and mitigate anything from happening further and to keep everyone safe downstream. The last, I'd say 4 or 5 line stops that we've done, we've had 0 blow by. So Johnny is very, very proud of himself for that. He sends us messages as soon as it happens, and we give him a big pat on the back. Again, this is just set up with your double block and bleed in line. What do I got for time here, Ben? Ah, okay. So gasket compression, and I didn't think I'd make it this far. That's okay. So again, as we talked about before, flange torquing, just make sure that you're following the proper bolt patterns and that you're torquing it. It's going to take you at least 3 times torquing in the proper pattern. Gasket compression, super important too. So we need to make sure that that pipe is going to have a proper seal on it in order for us to tap through it. Again, with AC mains and cast iron mains, size-on-size hot taps, we always use a stainless steel saddle with a full circumferential gasket to achieve that. And just the amount of pressure that it takes to achieve that gasket compression. Oh yeah. That's all I have for you today.
Thank you, Nichole. Does anybody have questions?
It was hard to see through the quick photos, but was that the double line stop you did, the bleed, was that the same size or larger than the main you were trying to isolate? Isn't that the requirement?
No, the bleed is, you know, it's this guy right here. That's going to bleed off your 115 PSI if we ever get to that point. it doesn't take much at all. So.
Okay, thank you.
So in the, you're saying basically that the manufacturer's now saying there's zero deflection allowed in a PVC pipe. Where would you find that? So I can say to a contractor, hey, here it is, right?
You can, if you ask IPEX for it, typically they will give it to you. They're never going to put in writing that you can bend a pipe, but you know, best practice is zero deflection.
There are a lot of
I
guys out there
know,
that-
yeah.
Yeah, this is how we've always done it.
Yes, yes, for 30 years before you were born. Yeah, I know.
Thanks.
No problem.
No more questions? All right. Thank you very much,
Perfect.
Nichole.
Thanks, everybody.
Wonderful presentation.